Okay. So solids number 5. Are you guys ready? Solids number 5. Volume of cylinders. Oops. Volume. Wow. Of cylinders. Are you ready? Okay, what's a solid in geometry? What's a solid in geometry? What comes to mind when you hear solid in geometry?
Like firm or something. I don't know.
Okay. What do you say, Charlotte? What's a solid in geometry? What comes to your mind at least? A square. So is that like a shape?
Yeah.
Okay, so shape. What else? Does that give you guys any idea? What comes to mind when you hear solid in geometry? What's a solid in geometry? Solids. What is that? Okay. Touchable. Tell me more. What about it is touchable? Okay. 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 So then switch to the word volume. If you had to explain volume, now you've got solids a little bit in your mind and you're going forward. How about volume? What's an easy way to explain volume to someone who doesn't know what it is?
Like the space inside a 3D shape.
The space inside a 3D shape. What's an example of that in your life? When do you use it?
Pouring milk in a cup.
Pouring milk in a cup. The milk you pour in the cup is a volume that fills in all the space inside the shape, right? And the solid could look a lot like the cup, right? Does this all kind of sound like what you're saying and you're putting everything together? So let's look at a cylinder. Let's go to this shape. You learned cylinders a long time ago, and I'm going to try to draw 2 of them. I'm going to try to draw one that's perpendicular, and I'm going to try to draw one that's oblique. Here's my 2 guidelines. Are those kind of parallel? This bottom one always goes a little slanted. All right, here's what it looks like. Let's do a circle up top. And then let's come down to something down here. Like this, and let's draw a dashed line. There. Not a very good cylinder, but can you tell it's a cylinder? All right, so if I fill this up with milk, this looks a lot like the glass probably you're using somehow. Maybe it's fancier, maybe it goes, a little bit more complicated of a shape, but we're gonna make it as uniform as possible at this point so it's easier for us to calculate, right? So we're gonna try to calculate the volume of this. What's the shape at the top? Circle. So I'm gonna try to draw a circle here. What do you remember about a circle? Warm up on a circle. What do you remember?
The radius.
Radius.
The diameter.
Diameter.
Circumference.
Circumference. That's pretty good.
Pi. I don't know.
Did you say pi?
Yeah.
That's perfect. That's about that's a lot, right? Anybody want to add anything else? That's a pretty good list.
The center.
Center. Nice. Do you remember the definition of a circle? You remember me a long time? This is like so long ago. I would draw like this.
Isn't like this? What was it? Huh? I don't even know.
If I do enough of these, what happens?
They make a line.
They fill all in with no gaps at all between them, right? This is back to the definition of a circle. The definition of a circle is the set of points that are an equal distance from the point called the center.
Wow.
I know, right? Wow. And you guys knew that before. That was a long time ago now, though. Okay, so center. So you know a lot of things. If I draw this, is this the radius or the diameter?
The radius.
How do you know?
Because it's from the center to the side of the circle.
How do you remember that? You're right.
Uh-huh.
I'm not saying you're wrong. You're right. But how do you remember?
Because the diameter goes all the way across and the radius goes halfway.
You just remember it? You don't have any, like...
Oh.
Like,
No.
You're right. You're right. I'm just wondering if, what I have our students that forget that from year to year, like they know it when they learn it, and then a year goes by and they can't remember which is which.
I just remember it.
I just remember.
Okay. Anybody got a system to remember? Do you remember me ever saying, man, this feels like forever. It feels like last year or something. That for radius, if you remember a word, that's something small. Rat.
And dinosaur.
And dinosaur.
Huh?
Oh my.
Was I not here for that? I don't remember.
So rat is small, so that's the smaller length line, right? Now, and dinosaur's big, so it's the larger length line. The D and the R. Does this make sense?
I think I
If you get to next year or the year after or the year after and you start to forget those, now you have to remember the rat and dinosaur, or otherwise it doesn't help you, right? So you're remembering something at some point. Okay, so perfect. So that's the radius. Here, radius, radius. Okay, do you remember? We need to find the area of this. How many dimensions is this shape?
2.
2. This is a 2D shape. But if you take the circle and you extend it now, you extrude it and pull it down, now how many dimensions is this shape?
3.
And so it's that third dimension here, the height, that we're going to multiply. If we can figure out the area of this circle right here, then we can multiply the area of the circle times the height of the shape, and we're going to have the volume for this. So what we'd really like to do is do area of circle times the height of the shape, that third dimension. Are you able to remember the area of the circle formula? You've known it before. You've known it a long time ago.
You like pi and then r squared. I don't know. That's not, I remember like the pi and then like there's the r and then there's like the to the power of 2 or something like that. I don't know. So, yeah.
I mean, that's really good. That's better than most. That's, I would say, if you're able to remember area is pi r squared, you're really doing well. What's the other formula that I would always mess up when I was in high school, which you don't probably know or remember, but do you remember the circumference formula?
Nope.
It's 2 pi r. And this would drive me nuts because when I was in high school, I'm like, well, they both have a pi, they both have an r, and there's a 2 in there, and I could never remember which was which. Why does area have the power 2 and circumference not have a power 2?
Because the circumference is like the line around, so isn't that like one dimension? And then like the area in the circle is the 2 dimension? I don't know. I'm so smart.
I could totally like sit down right now and you could just teach this. Yeah, I mean, that's absolutely right, and that's said exactly as good or better than I would say it. Okay, I'm amazed. Very good. I don't know what to say. Good job. That's a lot to remember and retain, and that's exactly true. That line around the outside, if you want to stretch it, that's your one dimension, right? Think of a string that was, going around a can of Coke, and you undo it and pull it tight. That's a one-dimensional shape, that line. And then once you go to this, it's 2D. And now we're going to multiply this down here. So for volume, we're going to multiply the area of pi r squared, that's the area here of a circle, times the h of the shape, and that's going to give us the volume of the cylinder. And likewise, if you go, what's the word that means that the shape is slanted?
Oblique.
Oblique. Oblique, oblique. I always say oblique because that helps me spell it. But so an oblique shape, let's try to draw that. Here it is here. And let's come over this way and do it like something like this and try to connect this to this and this to this and go dash, dash, dash. There's our cylinder now oblique, but notice the top and bottom are parallel to each other. So as this stretches out, this thing gets narrower. So it is longer, but it's narrower. And because we use the perpendicular height here, this h is the same as this h. What's another name for perpendicular height? Altitude. Okay, so and associated with a bird in the sky or an airplane or a helicopter, some way of measuring how high something is in space, right? We want to measure it perpendicular to the earth so we can tell that actual distance. Well, so notice the h's are the same, notice the areas are the same, so the volume for both, whether it's straight, it's perpendicular or oblique, is the same volume because they're calculated with the exact same dimensions. So now if we start to put some numbers in here, maybe we'll say that this radius here, r is equal to, let's use some simple numbers, 5, and let's use centimeters, and let's make h equal to 10 centimeters. And that's all we need. All we need is an r and an h. And now we can calculate volume. So volume equals pi r squared, let's rewrite it, times the h. Volume equals pi. The r is 5 centimeters, and put the units in with the r. So the units are being squared also. So the 5 will be squared and the units will be squared, times the height, which we said was 10 centimeters, and put in the units again. Do not change pi to 3.14 anymore. You've now graduated into leaving pi exactly how it is. Why do you leave pi, the symbol, in there instead of using 3.14? Why do you not use 3.14? It's true, it's not as accurate. The pi symbol is infinitely accurate because the symbol contains the infinite number of digits of pi. Isn't that brilliant? Maybe you don't think so, but that's genius. So we do less work and we're more accurate. We just leave the pi symbol in there. And somebody can calculate it when they need to. This becomes 5 squared, so let's separate that out. The centimeters become squared. The 10 is still in here. And there's another centimeters here. So the volume equals 5 squared is 25 times 10 is, we're going to put the number up front, 250. We're going to put the pi after it, so don't forget the pi. It's 250 pi centimeters squared times centimeters to the 1 power becomes, drum roll please, holy, that was good. Okay, and what does it become? It's to the power 2 times another centimeter to the power 1. And it's a volume.
3
Cubed. And this is the proof that our calculation is right, because all the units work also. It's a volume, so 250 pi centimeters cubed. Man, that was great. You guys are on fire today. What is going on? Okay, so it's the same thing if it's oblique versus perpendicular, as long as the area of the circle, so the radius is the same for both those, and then the perpendicular height is the same. That's it. We should stop there.